Alright, so since I can't be there in class today, I want to go through some more examples of just solving different equations, but this time we're going to take a look at what happens when you have no solutions or infinite solutions. So what I want you to think about is if you have two lines that cross. So when you are actually solving our equations, what you are doing here is you are looking for when do two lines cross? And when I look at here and I have these two lines, I see that they cross at one point. When I look at what that value right there is of x, that is what you are actually solving for. And eventually, we'll be getting into this, but when you're solving an equation, you're looking for where do the two lines cross. Well, you're going to come into some scenarios now where what happens if we have two lines that never cross? And when you have two lines that never cross each other, then we're referring to that those lines are parallel to each other, so they're going to have no solution. We also have two lines that share the same line. I have this line here drawn in purple, and then I draw another line right on top of it here. Notice that they cross at infinitely many points because they share every single point along the way. And so if two lines share the same line, you have infinite number of solutions. So once we get into our graphing, we'll see that here we're just looking at practicing with our solving skills. So I encourage you to use your note packet that we have, turn it to that last page, and we're going to look at two examples here. First of all, before I do that, let's just go through solving an equation. This one's not in your note packet. So I've just written up here 6x plus 4 is equal to 4x plus 26. So when we were working last week, we talked about how we want to solve when we have variables on both sides of the equation. I was kind of mentioning to some of you to draw a line down your equal sign to help you trying to get variables over to one side or the other. I am just someone who typically likes to bring variables over to my left-hand side. Some of you bring them over to the right. It really doesn't matter. Bring the 4x over to the left, so I have to subtract a 4x from both sides. That gets rid of it on the right. 6x minus 4x is going to give me 2x plus 4 is equal to 26. Now I can go ahead and get rid of that third wheel, so subtract 4 from both sides. That gets rid of the 4 over on the left, so 2x is equal to 22. And then now I can divide by 2, and we're left with x is equal to 11. So we got one solution right there. Now I want to take you to two examples here. One looking at, well, what does it look like when you have no solutions? What does it look like when you have infinite solutions? So these two examples are in your note packet, so make sure you have that and take a look at it. So if you take one look at the one that's over on the left, you have negative 4 times the quantity of 2x plus 1 equals negative 8x minus 2. So we have those parentheses. So we're going to go ahead, get rid of that. So use our distributive property. Negative 4 times 2x, negative 8x. Negative 4 times 1 is negative 4. And then we have that equal to negative 8x minus 2. Now, once again, I'm going to go ahead, I'm going to draw a line down my equal sign so I can make sure that I keep everything, whatever I do to one side, I do it to the other. So if I look at this problem right now, I have a negative 8x on the left, I have a negative 8x over on the right. If I were to go ahead and try and put these x's together, let's say I want to bring them over to the left-hand side. If I get rid of the negative 8x over here on the right, I would have to add 8x. So I'm going to do the same thing over here on the left side as well. Negative 8x plus 8x goes to 0. Notice it's happening over here on the left as well, negative 8x plus 8x. So I'm left with negative 4 is equal to negative 2. Well, let me ask you the question here. Can negative 4 equal negative 2? Are those two the same number? They are not. So that right there, because those are not equal to each other, that means that we have no solution. These two lines, if you were to graph them out, they would be running parallel to each other, so therefore they would never be crossing, making there be no point that they intersect at. So with our variables canceling out, we're left with this statement of -4 equals -2. Not true. Here, there's not a single answer that I can put in for x that would end up making this statement true. All right, let's take a look at the problem over here on the right. Once again, we have variables on both sides of the equation. We also have a set of parentheses here. So let's go ahead and use our distributive property. I'm left with -5 minus 9x equals 3 times 1 is 3. 3 times -3x is -9x. And then I've got the -8 on there. Make sure you don't distribute the 3 to the -8, only to the 1 and -3. I'm going to put a line down my equal sign once again. Over on the left-hand side, there's nothing that I can simplify. I can simplify, however, on the right-hand side. Positive 3 minus 8 would give us -5 minus 9x. So I have -5 minus 9x over on the left as well. Variables on both sides. Again, I like to bring things over to the left. So I see a -9x over on the right. So I'm going to add a 9x to that side. Whatever I do to one side, I have to do it onto the other. And notice what's happening here. Same thing that happened on the last problem. Our x's are canceling out on both the right-hand side as well as the left-hand side, leaving me with -5 is equal to -5. So now if you look at that statement, does -5 equal -5? That is true. This right here is saying that we have infinite solutions. And infinite solutions meaning that I can plug in whatever number I want for x, and we will get the same thing. If I wanted to plug a 1 in for x here, so 9 times 1 is 9. If I take -5 minus 9, I'm going to get -4. I can do the same thing over here on the right. 3 times 1 is 3. 1 minus 3 is -2. 6 times -2 is going to be 3 times -2 is -6. -6 minus 8 ends up giving us, I just got lost in that. Let me just write it down. All right, so we got 9 times 1, so that's 9. So -5 minus 9. So that's going to end up giving us here -14. All right. 3 times 1 is 1. 1 minus 3 then is going to end up giving me -2. 3 times -2 is -6. And if I subtract 8 from that, I also get -14. I could plug in a 1, I could plug in a 2, I could plug in a 3, I could plug in -5 if I wanted to. No matter what answer we put in for x, it will always be true. So on your page of notes, there are 4 additional examples. So what I would like you to do is to look at the first one. I want you to actually pause this video, try doing the problem on your own, and once you finish it, start the video back up and we'll see if you got the right answer. So go ahead and pause it. All right, so infinite solutions is our answer. If you got that, wonderful. Hopefully you got something like 6 equals 6. If you didn't get that, take a look and see where you may have possibly made your mistake. Taking a look at my work right here, I use the distributive property right away. Got rid of the parentheses that are there. Then another thing here is making sure that you combine like terms. 6x minus 3x gives me positive 3x here plus 6 equals 6 plus 3x over on the right. And then to get my variable alone, I subtracted 3x from the left-hand side, so I also had to do that to the right. And that was the cancellation of our x values, which left me with 6 equals 6. And that's a true statement. So we can say that there are infinite solutions. All right, go ahead and try the second one on your own. Once again, pause the video, and then once you finish it, start it back up. All right, with the second example here, you should have actually gotten a solution. The answer is x is equal to -4. So if you got that, go ahead and go on to number 3. If you did not get -4, take a look at what you did. First part here, you have to use your distributive property. 6 times 2x is 12x. 6 times -6 is -36. Distributive property over on the right as well. -7 times a -2x is a positive 14x. -7 times a positive 4 gives you -28. I don't have to do any simplifying on the left or the right, but we got to make sure that we get our variables on one side. So if I subtract 14x from the right, I have to subtract 14x from the left as well. And then it just gets me down to my final 2 steps where I can get rid of that third wheel of -36 by adding, and then we can divide. And our answer is -4. All right, so let's take a look at number 3. Once again, try and do it on your own. And then once you're done, start the video back up and see how you did. All right, so for the third one, this is a question that a lot of people get wrong a lot of times because they like to think that there is no solution to this problem, when really the answer here is 0. If you go through the steps, same thing that we've been doing, so we used our distributive property to begin with. And then once I've done that, I don't have to do any simplifying on each side. It's as good as we can go. And all of a sudden I notice I've got x's on both sides. I'm bringing everything over to the left. And so I go ahead and to get rid of the -18x, I add 18x to both sides. And now I'm at 58x minus 24 equals -24. To get x by itself, I need to take a look at that third wheel part and get rid of that. So I add 24 to both sides. Now here's where people think that right away that there's no solutions. Now when you take -24 plus 24, you get 0. Be aware that it's not your variable is not attached to that. Your variable is over there with the 58. So -24 plus 24 is 0. That equals 58x. When I divide both sides by 58, I'm left with now 0 divided by 58. 0 or divided by 58, 0 divided by any number is 0. And so you actually do have a solution here. The only time that these two equations would be equal to each other is when they cross on the y-axis when x equals 0. And so here, be careful that if you get something and goes to 0, it's okay. You just got to divide it out and you'll get your solution. All right, on to the last and final problem. So go ahead and do this problem on your own. Once again, pause the video, and then once you're done, start it back up. All right, your last and final problem, you should be able to get no solution for this one. And if you did not get that, just take a look at your work. Probably the biggest mistake is just up here in that first step. And once you use your distributive property here, -4 times x is a -4x. Then -4 times a -7 is a positive 28. So make sure you got a positive 28 there. You can simplify this left-hand side and combine like terms. 7x minus 4x is 3x, and 14 plus 28 gives us 42. Putting the variables on the same side, if I bring everything over to the left-hand side, I would have to subtract a 3x from both sides, and notice that right there your variables are canceling out, leaving me with -13 is equal to 42, which is not true, making it be no solution. So once you finish up watching this video, then you are to get your assignment that will be due then tomorrow. So hopefully you'll be able to recognize when you have one solution, when you have no solutions, or when you have infinite solutions.